Good morning to all. On behalf of PG and Research Department of Mathematics, DJ Vaishnav College, I welcome everyone to the national webinar on Introduction to Mathematica. Prayer is an opportunity to spend time with God. We will start our session with Tamil Thai Varthu followed by college prayer.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழே எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் மிகுந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनां नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Dear participants, your active participation is important throughout the program. You can post your questions and comments in the chat box. Feedback link will be posted at the end of the session in chat box. Now, I invite Dr. N. Jayan Karthik, Associate Professor, PG and Research Department of Mathematics, DJ Vaishnav College, to give the welcome address.
Good morning, everyone. Thank you for taking your time out and being here today. The Postgraduate and Research Department of PG Vaishnav College has been constantly striving to keep the students and faculty at par with growing knowledge through a series of webinars by eminent scholars from various domains. New fields of mathematics are being opened up by the use of computer software and tools which has enabled various complex mathematical concepts to be used to be very simple and easy to explore. Mathematica is one such symbolic computation program. It is a way to explore and enjoy mathematics. The knowledge of such computation program contribute significantly to the process of mathematics. Mathematics can be very abstract, but Mathematica can make it very simple. Mathematica can be used for numerical computation, algebra, calculus, matrix operations, and statistics. Mathematica was conceived by Stephen Wolfram in 1988. It is used across various engineering fields for data processing and visualizations and is available over the cloud. It can be used without installations. Today, on behalf of the Department of Mathematics, I welcome you all to the national webinar on Introduction to Mathematica. Thank you.
Thank you, sir. Now I invite Dr. R. Sivaraman, Associate Professor, PG and Research Department of Mathematics, DJ Vaishnav College, to introduce our resource person.
So our today's resource person, Dr. Jogendra Kumar, has more than 11 years of teaching experience. In particular, he has been associate professor at Dehradun Institute of Technology, DIT Dehradun, between the years 2009 to 2012, and he has been assistant professor at Galgotics University for 1 year between 2012 and 2013. And then he joined back, I think, as assistant professor again in DIT University, Uttarakhand, Dehradun, in the year 2013, and he is at present still there for the last 7 years. So totally, he has more than 11 years, beginning from 2009 until today. And if you see his achievements and publications and all those things, he had been very active in the past few years. I will highlight some of the prominent and important aspects of what he has given, because his profile runs up to 8 pages or so, so it's very lengthy. So we probably, I can just highlight some of the important achievements and things that he had been doing so far. He has participated and conducted 18 workshops, webinars, refresher courses, and other programs in 2020 alone. So beginning from January until today. So which means that he was very active in spite of this pandemic situation. He has been either participating or conducting some workshops and other things related to mathematics, which shows that he is very active and interested in the subject. And then he has organized more than 6 national and international conferences in the last 7 years. He has organized 4 workshops, FDP. He has organized 4 workshops, FDP training webinars in the past 4 years. And he has been resource person in latex workshop in March 13 to 14, 2020, organized by Department of Applied Sciences, DIT, University of Dehradun. He has given an expert lecture in the topic differential equations and its applications in engineering at Rajkiya Engineering College, Lucknow on 7th of November 2019. And he has delivered a technical talk in international conference on modeling and simulation of diffusive processes and applications during October 9 to 12, 2012. This is around 8 years back. So I think his active research work began some in the last decade or so. For 10 years, he has published so many things. In particular, he has published more papers in Scopus, and I saw in the resume that he has published 3 Springer SCI scientific indexed papers, which is very high value. So here is a person who was conducting all kind of workshops and doing so many things in mathematics apart from his teaching profession. So his more importantly, his citations were around 109 now, as of now, 109 citations. His H index is 4, his I-10 index is 4, which means that his work has been cited by so many scholars around the globe, and therefore this shows how prominent the speaker that we are listening to today. With this short introduction, on behalf of Department of Mathematics, DG Vaishnav College, I welcome Dr. Jogendra Kumar to present his lecture.
Thank you very much, sir, for your nice introduction. A very good morning to one and all. Jai Sri Krishna. Very first, I want to express my sincere thanks to the management, Dwaraka Das, Govardhan Das Vaishnav College, the organizing committee, particularly Professor R. Venkataraman, who given me this opportunity through which I can contribute something to academic community. Dear all, knowing a programming language is much required these days. whether you are students or faculty. The best programming languages are MATLAB and Mathematica, which are very good for faster problem solving. But when you will compare these two, you will see that Mathematica is better than MATLAB, particularly for scientific computing and graphics visualizations. There are so many problems which you encounter with in your project work, in your research, which cannot be solved analytically, but can be solved numerically. This is the time when
Excuse me,
knowledge
sir.
of your...
Sorry to disturb you, sir. Can you please share your screen?
Yeah, sure. Thank you.
Thank you.
Yes, is it visible? Is it visible, ma'am?
Yes, sir. It is visible, sir. Yes, sir.
Okay.
Yes, sir.
So I was telling that there are so many problems which you encounter with in your project and research work, which cannot be solved analytically, but can be solved numerically. This is the time when knowledge of a programming language is much needed, and Mathematica may be one of the best options. As you see, the name Mathematica sounds that this is the language especially designed for mathematicians, but this is not true. These days, almost every academicians from almost all backgrounds are using frequently Mathematica. The objective of today's presentation is to introduce you the Mathematica and its syntax, but especially for scientific computations and graphics. So let me discuss very basic of Mathematica through this PPT. Later on, we will move to notebook slide where we will execute some command to see results, and also we will try to visualize those results. So as you can see, the topic of talk is an introduction to Mathematica, scientific computing and visualization. As Mathematica, a professor from the VAISHNAV College itself has been told so many things, and I too. But you can see that it is being used in the field of neural networks, machine learning, image processing, data science, and visualizations. It was conceived by Stephen Wolfram and is developed by Wolfram language of Compan. The Wolfram language is the programming language used in Mathematica. Some popular version of Mathematica. Since the very first release of Mathematica in 1988, these are some popular version of Mathematica which are being used by the academicians, by the scholars. That is Mathematica 7, 8, 9, 10 and its extensions, 11 and its extension, and these days Mathematica is also Wolfram also has been released the version 12, and its extension is this year, 17 June 2020. We can start work with Mathematica either in Wolfram engine, through Wolfram kernels, or notebook interface, which is most preferable interface, Wolfram Cloud, Wolfram Alpha. Right. As you know that this is licensed version, but the beautiful things is that Wolfram has been given us opportunity to learn Mathematica through Wolfram Cloud, where you can create your account and you can work upon, and at the same time you can save your file to use this in the future. Let us talk about notebook interface. The very first we will write some Mathematica command. Then to execute this command, we will press Shift plus Enter. That is the procedure to run a program in Mathematica. And to exit from the program, you can choose the quit menu. So see here we have taken all these things we will do in the notebook slide. But as you can see, there are two numbers, float numbers, which we are trying to add. So just uh, write those numbers and press shift plus enter, and you will see the result, right? And this is the exactly display which you will see in notebook slide just after this PPT. These are some shortcut key which are very useful for smooth writing of your syntax. If you don't know these shortcut keys, no problem. There are palettes where we can find some assistance for mathematical writings. But you can see for power we can use control, for subscript, for square root, for fractions, right? So these are some basic shortcut keys which we can use to write our commands. Then numerical calculations. You get exact results with Mathematica and unless you request otherwise. What is meaning of this? If you are going to find some numerical calculations, the outcome will be always exact until unless we ask for numerical results, right? So see, here we have been 2 power 100, which value is this, but we can find numerical value of this, which is 1.26765 into 10 power 30. You can see this is the numerical expressions. Similarly, there are two fractions you can see. We can add this, just press shift plus enter, and again you will find the exact result. If you are interested to know the numerical, then again you have to give the command /n. N represents for numerical results, and you will find the numerical value. If an input number contains an explicit decimal point, as I told you earlier, that we will obtain always exact result, but there may be a condition where you will find numerical results. What is that conditions? If input itself is a numerical value, that means number is floating, then the result, the outcome will be numericals in floating form. I mean to say, as you can see, this first fractions contains floating points in numerator, and so the result will be numericals, not exact. These are some inbuilt functions, but there are thousands of inbuilt functions which are enough, at least for science background peoples, to execute their commands, right? So the basic things we have to be careful that any functions start with capital letter. As you can see, the very first one, square root x, the s is the capital letter. Similarly, exponential x is the capital letter. You can you can see throughout the row that the first letter is capital letter. We will execute all these commands later on. We know that there are three general brackets. One is round brackets, another one is curly bracket, and then square root brackets. We use round bracket in Mathematica to compound sentence, and we use curly braces especially for list. And the arguments of every functions will be enclosed by square bracket, right? Here in the last section, you can see, unless we will give this command option, decimal point is present, Mathematica tries to output exact value, that I have been told earlier. These are some general constants which we use frequently in Mathematica, that is pi. We use capital letter E for exponential, E, degree, that is pi by 18. Again, you can see the first letter is the capital letter. So that means any inbuilt functions, whether it is functions or constant, the first letter will be capital letter. Again, if you are calculating some numerical values and there are so many numbers, then we can define the degree of precision. Like suppose you can see here, we are interested to know the value of pi up to 30 precision. You can see after decimal there are 30 digits. Similarly, here we are interested to know the square root value of 7 up to 7 precisions and 10 precisions part, sorry, and you will find that one. To use previous result in your next calculation, we can use the percentage options. See, if we are using percentage, so we will, that means we are using the previous results, the very first previous results. If you are going double percentage, then the second result, second last results, and percentage n's represent the result on output line out n. So all these things we will see on Mathematica notebook. Percentage is always defined to be the last result the Mathematica generated. It can be anywhere in the script, right? That we will see in the notebook slide again. Variable definitions. X equal to value. That means we are assigning a value to the variable x. So that will be given by equal to sign. The same value is given here, x equal to y equal to value. That means the same value we are assigning to x and y. And this is x equal to dot or clear x, remove any value assigned to x. Remember, please keep in mind, Mathematica is case sensitive. To avoid confusion with built-in function, choose name that start with lowercase letters. Suppose we are interested to naming some results, so we should write those names in small letters, because as you know that in built function is start with capital letters. To avoid any type of conflict, we will write in small letter. Again, the next thing is xy, mean x time y. Please see that there is space between x and y. You can see x space y. Here you can also write x star y. That means that is the product of x and y. Xy, if there is no space between x and y, that means this is one argument, right? With no space means variable name xy. That means we are defining only one variable, that is xy. But at the same time, if there is one numeric value and another one is variable, that means multiplication of these two. 2x means multiplication of 2 into x. These are some numerical functions you can see. If you are interested to find integer part of x, we can give this command, fractional part of x. We can give fractional part x command, round x, floor x, ceiling x, rationalize x dx. Here dx means up to dx tolerance. Dx is the tolerance. That means we want to rationalize x within the tolerance dx. These are some results we obtain through these mentioned inbuilt functions. Similarly, we will define complex things in this form. X plus capital IY, that will define a complex number. Real part object, we will find real value object. Through imaginary object, we will find imaginary value object, and in that way we can find conjugate object, absolute value object, and argument object. These are some solution of real equations. So I am leaving this right now. We will see all these things on notebook slide. Symbolic calculations. Right, symbolic calculation means whether we are interested to find derivative of functions up to nth order, integration of functions, whether it is single integral or multiple integrals. Sum, we are interested to find sum of functions. We are interested to solve equations. We can solve with this command. These are standard structure, standard syntax in Mathematica, which we can use to solve our problems. To generate a series of a function about a point x naught of order n, right? What any order, you can define order here, but finite, remember. So we can generate a series for the same. Similarly, we can find limit of a functions. We can find minima or maxima of functions, minimum value of functions. This we will do there in Mathematica slide. The Wolfram language has many ways to plot functions and data. that is very important configuration of Mathematica, which are being used extensively by the students and faculty who are doing work on their problems. So we will see through this interactive notebook slide how to visualize the results. These are something about error handling, something. If there are some this kind of errors, so that will indicate what kinds of error is there, and accordingly we can remove those errors. Let us start our presentations are on Mathematica notebook itself. That is much better than this PPT presentations. So let me share that. Please stop me if there is any kind of, I mean, if you are not listening me, if you are not able to see the screen, please let me know. Is it visual, ma'am?
Yes, sir. Visible, sir.
Am I audible?
Yes, sir. Audible, sir. Yes, sir. Audible, sir.
Yeah, thank you very much. So see, the very Wolfram language, there are very basic rules. The very first thing that capital letters on all commands names. As I told you earlier, surround the function arguments by square bracket. Curly braces are used for list and ranges. And to execute a command, we will press Shift plus Enter. But remember, to execute a command in notebook interface, we have to press Shift plus Enter. But if you are working on kernel or some text-based interface, then Enter key is enough. Then we have to hit Enter only. But if you are working on notebook slides, notebook interface, then to execute a command, we have to press Shift plus Enter. To help you to write your commands, there are palettes given in notebook. That is basic math assistance. If you are trying to write some presentations, then you can find assistance from classroom assistance, writing assistance, and slide slow. So you can see itself from here. You can see this is the palettes where we have basic math assistance, classroom, writing assistance. So you can see from here. If you need some kinds of special characters, constants, in fact, notations for differentiations, integrations, right? You can use here, right? If you want to define a matrix, subscripts, superscripts, some special letters like del, right? Capital D, that is. You can see all these symbols are here. You can use these basic math assistance. Similarly, you can use classroom assistant. I'm not going to discuss all these things, but once you will go through these things, you will be familiar with the notebook interface. Let us see some basic calculations. To see again here 2.3 plus 4.5. Now what we need to do, just we have to press Shift plus Enter and we will find the result. You can see that is 7 plus 2. Again, we have mentioned this 2 power hundreds. When we will execute this command, we will get this number. This is exact value of 2 power 100. Right. Now, if we are interested to write only 10 precisions, then we have to command this as well as the numerical values. So we have to write capital N for to get numerical values of 2 power 100 up to 10 precisions, right? Then again we have to press Shift plus Enter. You can see this is the value. Again you can see these are two fractions. When we will execute this one, we will get a fraction, right? But here, as you can see, there is a fraction with floating points, and so the outcome will be floating number. You can see here. Right. Similarly, If you are interested to find a square root of 2, we will find this one. We just symbol there. But if we are interested in numeric value, then see, that is 2.1. When we will press shift plus enter, we will get a numerical value of square root 2. Same for n pi 100. That means we are interested to find the value of pi, numeric value of pi up to 100 precisions. You can see, right? Suppose you are interested only in 10 precision, then this and hit this. You will get this. There is no issue. So there are so many basic calculations. So that will be better idea to start with basic calculations, which will develop confidence within you. Then there are some basic commands. Suppose we have an expression, polynomial expressions or any kind of expressions, and we are interested to find factor, expand. Then we can do all this with these commands, right? Here we have a polynomial of degree 4, you can see. And if we are interested to find factors, again we can press shift plus enter, and you will see the results. Here all have been run. So let me run one by one. Right. Let me go plus 5x square. See, there is a star. That means this is multiplications, right? So, in place of a star, we can write, we can put there space between 5 and variables. So there, if there is space, that means that is multiplications. Now let us execute the second one. Yeah, I think there is some mistakes. So let me keep this. Yeah, so we can write this in here. Let us execute this one. Expansion of this. We will get expansion of this. Similarly, if you want to run the last one, so this, see, if we put this semicolon, this colon, that means the Mathematica is not going to, it will run this command, but not give the results there on the screens. Right. Of these expressions, you can see the same exercise can be done with this postfix form. Postfix form, you can see forward double solution. This one, right? Suppose we don't want to this result and want this, then we have expansion, you can see. So we can do this exercise either by postfix form, or we can give these commands to find factor, expand, and we can simplify expressions, right? Now the very important segment of Mathematica is symbolic calculations. That means we are interested to know derivative or integrations of functions. You can see here we are interested to find derivative of sine x square with respect to x, right? So when we will execute this, this is the result, 2x square. This is very fundamental functions, and you can verify the result at the same times. Similarly, we can find the result derivative of these functions, right? Now see, this is again derivative of these functions, right? But here we have written x comma 2. That means we are interested to find second order derivative of this. Second order derivative of this with respect to x, right? So let us see what is the second order derivative. You can see that is 8 plus 6x. Similarly, we can find integration of sine x. This is definite integrals, which limits are 0 to pi, right? So this is syntax to find integrations of. What we need to do, we just integrate in square bracket functions, and in curly braces there are integral limits for the variable x, and you will get the value 2. You can see. Similarly, we can find integration of these functions. Now see, there is x3. That means we are interested to find third order derivative of this function. Third order derivative. So let me run this. Just press shift plus enter and we will get this value. All right. Now what? See, now we are interested to know this result, to find this result when we are assigning a value, not only to x only, but k, but for k2. You can see this notation is called replace all, right? Here we have defined the solution, the third order derivative of this function by f. You can see. So this is the expressions which represent f. Now we are trying to know the value of f when x is 1 and k is 3, and again we are interested to know the numerical value. That is why we have given double forward slash n. So this is the command. This is command replace all. That means wherever there is x in f, replace all x by 1. Wherever there is k in f, replace all by k3. And not only this, at the same time find the numerical value of f. Then again enter. We will see that this is 406.337. All right. And the same command, as I told you earlier, can be done with this command, right? Whether you can do the same by postfix form or you can give the command capital N. So see, let us verify. You see, we obtain the same results. Similarly, these are some integrations. This is some functions, and we are interested to find integral of this function. And this time, this is indefinite integral. You can see there is no integral limits, right? So this is the indefinite integrals, and this is the value of indefinite integrals, right? So, similarly, we can find the integral of this one with respect to q. Here we have variables p and q, but we are calculating different derivative of this one with respect to q. Which is this? And if we are interested to find the numeric value of this one, see here I have written %1 and %2, right? This time this is not true here, so let us left this. We can simplify this one, which have been discussed earlier. Let us come to the double integrals, right? So suppose we want to compute the double integrals, this one, then what is the command for this? Integrate. This is the integrand x plus y, and then we will write the integral limits in list form, right? So this is x1 2. This is the limit for x. Lower limit is 1, upper limit is 2. Similarly, lower limit of y is 2x and upper limit is 3x square. So we can evaluate this one by pressing shift plus enter. This is 1789 upon 16. You can see. Similarly, we can evaluate triple integrals, right? See, this is the integrand, and we have to give 3 integral limits, right? Here we have written theta, but you know that this is definite integral, so we can write t. There is no issue, but you can write theta here, no problems. So this is the limit for theta. This is the limit for r. This is the limit for z, and we can evaluate the same. This is 381 pi upon 7. Similarly, we can create a list and part of list and expressions. We can create a list. See here, I have defined. I am creating a list and I am giving the name that list by my list, right? And I have started the name of my list by small letter, because you know that capital letter is protected for inbuilt functions. So whenever you are going to define your own functions, you are going to naming a result, then you should start that with small letter only. So that is my list. Range 10 means we will get a number from 1 to 10. You can see 1 2 3 4 5 6 7 8 9, and you can see this is in curly braces, and that is why this is list, right? Again, we want to create a list from 1 to 10, but there is difference between two consecutive numbers, right? That is 2. So that means when we will execute this command, we will get a list which will start from 1, then we will get 3, 1 plus 2, 3, then we will get 5, 3 plus 2, and so on. And that will go up to 10. You can see 1, 3, 5, 7, 9. If you want to reverse of this list, so just command the reverse, you will get this one 97531, right? If you are interested to know the maximum value of this list, execute this command and you will find maximum of this. If you are interested to find the average of this list number in the list, just execute this command. If you are interested to know the total of this, you can exercise with this my list, right? So this is this time I'm trying to know the my list square plus 1, which is divided by my list. So you can do exercise as per your requirement. So these are some fundamentals which we can see, and it will make you comfortable with the mathematical language. Now see, this is slicing of list. I have written here my list second, right? This is the syntax to slice a list. So you can see what is my list. This is the my list. Now I am interested to know the second element of my list. So when I will execute that command, I should get 2. Let us see. Yeah, you can see 2. Now what is this? Again, we are interested. My list, we are slicing the list from 1 to 4, right? We want to know the elements of my list positions at 1 and 2nd and 4th. So what are those? That is 1, 2 and 4 at itself. So let us see 1 to 4. This through this slice command, we can find the numbers from list from the position 2nd up to 4th, right? Again, we will get 2, 3, 4. I hope, yeah, 2, 3, 4, right? These commands are also useful in getting part of expressions, right? So see, there is a mathematical expressions. This is polynomial of degree 3. If you are interested to know what is the length of these expressions, you can execute this command, which is length of f. That is 3. You can see. Again, we want find the first expressions of these functions. You can find this. There is something wrong. That's mean why it is being, because we have defined f somewhere else, right? So what we should do, here clear f, and then we'll execute, right? Now you can see this is f. Now length of 4 will be length of f will be 4 because there are 10th 4th term. Now first element of this function, that is 10. Third element of this function, that is 3x square. So similarly, we can find other results. But see, once you have defined a variable, a layer in your calculations, then you have to be careful that if you are going to assigning something else to the same variable, then please clear the previous values of f by this command, right? If you want to clear more than value of more than one variables, then you should write here clear all, right? And again, clear is also useful there, no problem. Similarly, we can do exercise for this function here. Now see how to define a function. That is very important, right? So function can be defined with an equal to sign and colon equal to sign. This is called set or set delayed, right? For example, this we have defined two functions, fx, sin x power 3 cos x, gx. So this is the way to define a function. Suppose we want to define fx. This is the function sin x power 3 cos x. Then here we have to write f in square bracket x underscore. Here we can write equal to sign and colon equal to sign. What is the difference between these two? Let us understand. But since we have used the symbol f and g earlier here, So very first we should write here clear, right? So that they are clear, right? Now, if you want to show this result, you can remove the this one and you can find the result. If you don't want this as outcome, here put this and explain, you will not find the value of f and g. But here you see what is the difference. What I want to tell you, what is the difference between these two signs? As we can define function with these two, there is no issue. But this is not useful every time. See here in this example, we have a function sin x power 3 cos x. Now suppose we are interested to find derivative of fx and then value of f, right? Here f is what? We are interested to find derivative of this. So if we are interested to find f50, let us see what happens. Yes, we are getting. Let us, yeah, and let us do same with this command. G. See, there is error. 5 is not a valid variable. What is the reason? Here we are getting value of f50, right? What is f? Derivative of this function, you can see. Here with this command, we are getting the value of derivative of this function at 5, right? What is x3? That means derivative of third order derivative of sin x power 2 plus x, right? And we are getting value of third order derivative of this function at 5, that is minus 1409. But here we are not getting. So what is difference? See here. You can define function with equal to and colon equal to, see the difference. But there is a difference between using this. When equal to is used in defining a function, then right hand side is evaluated before the value of x is substituted. What is meaning of this? When we will use equal to sign, then very first, suppose we are finding this derivative, then what we will do the Mathematica will very first differentiate this one, and after differentiating this, Mathematica will substitute the value of x, that is 5. But with colon equal to sign, very first Mathematica will replace value of x here, right? And see, that is why all this become, this is not variable now, and so we cannot differentiate, and that is why there is error. You can see. Then the right hand side is evaluated before the value of x is substituted. Whereas when colon equal to is used, then the first x value is substituted and then the right hand side is evaluated. That means when we will use colon equal to, the very first this 5 will be, x will be replaced by this 5 here, and then Mathematica will try to differentiate. And since there is no variable, and so there will be some error, right? So we have to keep in mind what is our objective, what we want to do with the defined functions. I accordingly define the functions either with equal to sign or clone equal to sign. All right. We can solve a polynomial equations by using solve commands. Right. You can see we have a polynomial equation x square minus 3x plus 2 equal to 0, and we are trying to solve this for x. You can see, so this is the standard syntax. Now just execute this, you will find the value of x, that is 1 and 2. See, this result in list form, right? This is result in list form. If you want to find another form of these solutions, you can write this one. This is the replaced all, right? We are writing this in list form. You can see this is the first element. Again, there is another curly braces. So that means we are writing this result in list. The second curly braces indicates that this is a list. Similarly, we can solve with solve command system of equations, that is x plus here x plus. At the same time, see, if we are assigning a value to a variable, we put only one equal to sign. But when we are writing an equation, there will be two equal signs. Please keep in mind. If we have to just assign a value to a variable, there will be one equal to sign. But whenever we have to write an equation, there will be two equal to sign to write equals, right? So let us solve this one. To execute this, press shift plus enter. Here are the values of x and y, right? Again, if you want to write this result in list forms, you can replace the, see there is percentage. That means we are giving this command for the previous results, right? So whatever we want to do with this results, so we can write here percentage. So this is the just previous results, and this is for replace all, which I will mention you later in the next part of the slide. By rule, right? This is the rule. What is rule to replace the results? That is list. So that is why we will get answer in the list form, you can see. So now this is the first element, right? So when we will write this same in the list form, so there will be curly braces. One will be here and another will be here. You can see this one. Again, here I am trying to write whatever is the solution. I want to mention that solution with my solutions. When we will do this one, when we will name the solution by our side, if you have to do some exercise in next section with this solution, then it is good practice to write to name that solutions. So what will be benefit of that? Later on we can use that name to work with that results, right? So suppose here we have a solution. See, this is the solution, right? This is in a get form, you can see. Now if you are interested in numerical value, you can give this command n my solution. So this will be numerical value. See, x equal to 1. Now this is floating, you can see floating answer. Here we have exact expressions, but here we have numerical values, right? So here again my solution 1. So see, my solution is the list now, no? See here, my solution is the list now, because here is the curly braces and here is the both solutions are enclosed in curly braces, right? So if you are interested to just keep these results, then you can slice that from list to my solutions, and that is the syntax to get the first result. We will get the first element of the list. You can see that is here, that is x equal to 1 and y equal to -1. Similarly, these are some expressions, and if you are interested to know the numerical value of this, you can replace value of x, y. This is sign for replace all, as you can see. Here we will write the value of x and y in list form, because there is more than one variable to whom we are assigning. We are assigning x the value 2.908, and we are assigning y the value 1.8062. So let us see what happens. We will get this value, right? Similarly, we can do this exercise. See, the same things we can do. Here we have replaced all x by this list. You can see there is x. So the same operation you can do with by slicings. What is third element of this? See, third element of my solution, that is this one. This is the third solution. All right. So if you want to know the value of this one, where x is this and y is this, you can write replace all my sol 3, and since this is exact number, right? Here we are interested to know the numerical values. That is why we have given the command postfix command, and to get numeric results, press this, we will get numerical values. Now suppose, see, Mathematica automatically gives the number in some standard forms. If you are interested to know the all values, what we need to do? Write number form of this, suppose up to 16 precisions, right? So let us execute this. You will get other numbers which was truncated earlier by Mathematica. You can see that this is the value of this value is nothing but value of this one. but these two are different, because here Mathematica automatically truncated other numbers. But if you want to know what are the other numbers, you can do exercise with the number forms. Similarly, you can solve this one. This is polynomial equations. Here I am naming this solution by S1. Right. So what I am doing, why I am naming? Because I want to do some exercise with these solutions. That is why I am naming these solutions. So this is the solution. We have three values of x. Now suppose we are interested to know numerical value of this expressions for x equal to this. So either we can write, let me see, either you can find the numeric value of this one for value of x, this value of x. You can give this command, right? There is, yes, and this is this. Similarly, if you want to do this exercise, you can do the same. Let me show you. You can do this same, just writing this one. It is closed. Let me execute. You will get same value. Further, you can replace all x here in this function either by this command, or you can use slice form, right? This is sliced. Similarly, you can solve this one. I think this is not necessary. We have done a lot. Now, what if equation is not polynomial equation? Is solve this syntax solve will work for the equations other than polynomial equations? Let us see. This is solve, right? There is error, right? You can see there is n solve. If you are interested to know the numerical value of the functions, numerical solution of the polynomial equations, at the place of solve, we can give command n solve, right? So let us see, can we solve this by n solve? No, again there is error, right? So that means if there is there is transcendental equations, then command of solve and unsolve will not work. In that case, we have to use find roots, right? See, this is non-linear equations, as you can see, cos x, there is cosine x. So we can use find roots of this, right? As we do in numerical analysis, right? In numerical mathematics. So to find a root in numerical analysis, you know that we give some initial values to x. That means we are we trying to know the value of x in the neighborhood of a point, like in I tell you Newton-Raphson methods, like that. So here find roots of these equations, which is transcendental equation, you can see, and we are interested to know the roots of these equations in the neighborhood of 5, right? And that is why we have given this initial value. So let us see what happened. So this is the value, this is the solution. You know that roots is nothing but solution of equation. So this is the solution of this polynomial equations near 5, right? So similarly, you can do exercise. Let us do the same near -5. See if there is any result. Yes, there is a result. There is a solution that is -4.54862, right? See, this is the function which we defined, and we want to plot this one. This is sine tx, a function which want to plot between 0 to pi, right? We will discuss plotting later on, but see what happened here. So let us execute pt. We will get here these functions, right? So see, this value of here we have been given command for x only, but there is one unknown also, t. That is why we when we will plot this one, you can see we are giving values for x only, not for 2, right? And we have defined so function in term of t. Here we are giving value 2 to t, right? So that means this is plot this is graph of sine 2x, right? Because here t is 2, right? Similarly, you can give another value 6.3. You can see 6.3. You can manipulate this. If you want some kind of animations, you can use command manipulate. You can see we are going to use manipulate command for the same function, that is pt, right? Let us see what happened. Here you can see we are giving the value of t from 0 to 10, right? Here we have considered the graph of these functions for 2 and 6, but through manipulate we will see the graph of the same function where t is taking value from 0 to 10. Let us see. See, so there is when t is 0, there is no graph. You can see when t is 0, there will be sine 0, right? And sine 0 is 0 itself, you know that. So that is why we are not able to see a graph. So what we will do, we can increase the value of t. You can see as you increase the value of t, we will get the graph of the functions. As the value of t increases, wavelength is decreasing, right? You can see. You can do this same by automating. Just play. You can see. Right? We can use the same command to expand. Suppose, as you know that a plus b ka whole square, a plus b ka whole power 3, a plus b ka whole power 4. So in some power we know the results, but what if n is increasing, right? So again we can find all those expressions using manipulate, right? Here we have defined a function, that is expansion n, right? That means we are defining this for n only, that is a plus b ka power n. Expand this, right? So here you cannot see the result because I have given there this one. Now you can increase the value when n is 2 this, when n is 3 this, when n is 4 this. Again you can play the same. From this will n will start from 1 and see n is going up to 10, and the length between two number is 1. That is n will take 1, then 1 plus 1 2, then 1 plus 2 plus 1 3, and it will goes up to 10 like this, and we can find the expansion of a plus b power n for the values of n between 1 to n, and you can do the same for large number, right? Then some conditional execution of some conditional statements. So again we have been given clear fx, clear all fx command, because in past we have assigned the value of x, right? In previous calculations also we have assigned expressions for f, and that is why we are clearing all these things by clear all fx command. Now we are defining fx. What is this? That is minus 2x. This fx is defined minus 2x for x less than 0 and 3x otherwise, right? So which we can write with this command. If x less than 0, so that will function, this command will take minus 2x. So this condition is valid for the very first arguments. You can see the very first we will give the conditional statements, then for that conditions the value of f, and this is the value of f other than these conditions. You can see other than these conditions. So suppose we have defined this. Suppose we are interested to know the value of this function at 3. So at 3, what is 3? That will come in otherwise, because x is 3 is not less than 0. So what should value of f3? That should be 9, right? Let us see. Yeah, here it's saying that fx is protected. That means that we have assigned there. So what can we do? If sometimes clear all is not working, of course it should work, but if by any case it is not working, then you can do what? You can go there in evaluations and quit the kernel, right? So what happens? Now all the earlier commands will be not execute, right? And so here we have fresh start for F. So let us see here now. Okay, again there is, but we are getting value 9, right? There is a tag protected fx. That's mean we have defined earlier the value of f and x, but we are getting value 9. You can see. Similarly, we will try to know the value of minus function at -5. Let us execute that. Remove this and shift enter. That is 10, because x -5 is less than 0, and when x is -5 to -2 -5, we will get 10, right? Similarly, we can work out for compound conditions. Suppose we are interested to know the value of a function when x is less than 1 or x is greater than 5, right? So see here, if for the same function, we are doing this exercise for the same functions, x less than 1 or x greater than 5, then outcome should be according to -2x. If we have conditions which is beyond these two conditions, then we will get the value of function from these sections. So let us see. f3 9. So what is 3? 3 is belong to this. 3 is neither less than 1, you can see, nor greater than 5, and that is why we should get value of function from this segment. That is 3 into 3, we will get 9. Let us do what happened for f -5. Let us execute. We will get 10. See, -5. So there is one condition. So the function, this command will execute this one if any one of these two conditions will be true. Either it is true to get value from this, or this should true to get value from this. If both are not true, then we will get value of function from this part. All right. Similarly, there is AND sections, right? What is AND? For AND, we can use this one, or we can use this, right? So AND means, see here, just I want, because we have time, less time, I'm leaving right now these things. Similarly, you can define finite sequence and series. In fact, you can find Taylor's polynomials. So see, suppose we have to find some of these expressions for n starts 5 and goes up to 69. You can write n sum, right? We are interested to know numerical value of sum. So we can write the function itself. In the second curly braces, we can write the value of n. This is, well, here I have written 1. Let me write this 5, right? Because here n is 5. Let me execute this one. This is the value. So see, again, by default, Mathematica had truncated the other numbers. If you want to see those numbers, express this. So these are other numbers. No, this is the expansion of this number, right? This is not related to this previous result. Similarly, we can create a table, right? For n square, when n varies from 3 to 10, you can create a table. You can see table will be in the list form itself. So that is 3 chi square 9, 4 chi square 16, and so on up to 10. Similarly, we can create a table for the same expressions, but the condition is there is a jump of 5, right? That means n will start 3, then next number will be 3 plus 5, 8, then next number will be 8 plus 5, that is 13, and so on. We will get, see, we will get this result. 3 square, that is 9, 3 plus 5, that is 8 chi square 64, and so on. Similarly, we can create table for this, right? We will get here sine of x for different values of k, you can see. Similarly, you can expand log x in power of x minus 1 up to 7th degree, right? What is meaning of this? We are interested to find a series of log x in power of x minus 1, right? and this is given here for up to degree n. So let us see. See, we have expansion of log x in x minus 1 up to degree 7. This is the remainder term. If you don't want this, you can command, you can write, you can name this series, the same series, like here. Let me execute. I don't want to execute this because we have done here. Now, if you don't want this term, you can give command normal poly, right? You will get, you don't get here this one. See, there is no remainder term here. Similarly, you can do vector operations. Let me do this firstly because I want to show some graphical results. This is a vector in list form. This is another vector. You can see, you can find product of these two, dot product, right? You can find here length of square, length of v, right? How can find length of v? Means square root of v into v, right? So this is dot product up to this vector itself. So let us see what is the value of this. This is square root 62. Similarly, here we have two vectors. We can find cross product of these two vectors. You can see. Similarly, we can find unit vectors for v, right? This is unit vector for the vector, this one. This is the row, right? If we have defined a row in matrix. If you want this, if you want find this one in matrix form, you can give this command, right? Okay, let me run this very fast, and then you can execute this one. You can find, right? This is column, right? There is another matrix. The same you can find from the postfix command, right? You will get the same one. You can see. Here is another matrix of 3 by 3. You can see this is the row. If you want to write matrix form, again you have to run this one very fast. Then you can find matrix form of this. You can see, right? You can find transpose of the same matrix in matrix form, inverse of this, right? Determinant of this. These are the elementary things, and for a beginner, these are very good things so that you can gain some confidence for the rest calculation. Let us come to the plotting, right? So there is these are the some standard result to plot a functions. This is function. Then we will give the range of functions. This is x, minimum value of x, maximum value of x. For the same range, we can plot more than two functions, right? Similarly, we can plot a function not in a range, but we can give a command a region, right? So let us see. This is a function which we want to plot in -3 to 3. That is the graph you can see. Similarly, here you can see there are two functions. One is x minus x square, and the other one is 1 minus 2x. So if we have more than one functions, we will write that in list form, and then we will give the range of x. Let us execute. This is graph of this, right? You can here we get automatically this color for different colors. If you want to know which graph is the for which functions, then here you can create plot label, right? No, sorry, plot style. Let us say for the first function we want red. The red graph will represent graph of this function, and the other we can give blue. Let us see the red one for this and the blue one for this. So in that way, if you can if you want to write, you can give plot levels, all right? So let us see that expressions. जो हमारे expressions हैं, what are the expressions that is plot levels, right? Okay, there is some mistakes, I think. Let us move to the next. So we have done this. Similarly, we can define access level. See, there is no name of access, right? So what we can do, we can give the access name. Now there is access, x-axis, y-axis, right? There is plot style access. you can fix the aspect ratio. What is aspect ratio? That is the ratio of horizontal and vertical uh, axis. You can plot tangent of this, right? Now see, this is very good command, exclusions. All we know that tangent of x is not defined at minus pi by 2 to pi by 2, which lies within this range, and so we can exclude these values from this range by this command, and we can plot the graph. Right now, what if we suppose we are not doing this command? You can see again we are getting okay. But exclusion is the good command when there is in the function, there is a point within range where function is not defined. Similarly, we can plot legends. Right here we are plotting three functions: sine x, sine 2x, sine 3x for x 0 to 2 pi. So we can plot this one. See, plot legends. Right here you will note that blue graph represents graph of sine x, the next one sine 2x, sine 3x. In that way you can define plot legends. These are some basics of plotting. Similarly, you can give expressions, right? See, plot levels, expressions. That means either we can do plot legends or plot expressions. So through that you can identify which graph is for which function, right? Suppose you want to fill by color of some graph like this, right? We have a function 2 sine x plus x. Within this, we can do this. We can fill the graph bottom, right? Between two graphs. See, here we have plotted two functions, this one and this one. Now we are plotting this one, and we want to fill the space between two graphs, so we can give these commands. All these are in inbuilt functions. Similarly, we can do contour plottings, right? 3D plottings, especially for surface. When we will solve partial differential equations, yeah, if there are two variables in expressions, so we will plot the that expressions by plot 3D, right? We will see this later on. Replace all. I have told you earlier, replace all. Just suppose clear all x, y we have been given. Run this. We get these solutions. Now we are interested to know the value of ax from the second list, right? Let us execute. We will get 1 upon root 2. From this command, we can get the value of y from the first list. See, from the first list, the value that should be minus 1 upon root 2. We have this. Let us see quickly how to solve ordinary differential equations. So we can solve ODE with D solve and ND solve as well, right? So we have a solve. These are the syntax. D solve equations. This is the unknown. This is the dependent variable. This is the independent variables, right? So we can solve for this for x only. We can solve the same differential equations for a range of x, right? For a region where x is defined, like that. You see, suppose we have a differential equation. You can see this dy by dx plus y sine 3x. Very first, I have cleared all these things because there should no error. And we have defined solution of this one by, I am giving name of solutions of these differential equations. I am giving command D solve. We will write dy by dx y prime x, right? Because y is function of x. We have to write this in square bracket. Similarly, plus yx, again y is function of x, equal to double equal sine 3x, right? Sine 3x, and then this is the syntax to solve the ODE differential equation. Let us run this. We have the solutions here. Since this is not IBP or BBP problems, this is not initial value or boundary value problems, we will get arbitrary constant. This is a differential equation of order 1, and so here we have a arbitrary constant, that is C1, right? Now what? Suppose we are interested to now I am going to write this part only, right? So see, this is in the list, right? There is only one list and we are interested to know the first value of this list. All right. So we can write yx, replace yx. This is replace all by list 1. All right. So we will get this one when we will execute. You can see here, this one. Now I'm giving the value of C1, right? Suppose we want to see the solution curve. In that case, we have to provide a value to C1, right? Here I am giving the value of C1 as 1. I am assigning C1 a value 1. Let us run this, right? So I don't think we can write here percentage, right, for previous result. Okay, now we have given C1. This is not correct. See, this is not correct, because if you are assigning value C1, so we should get this value and where this C1 will be 1. So to do this, let us write out and see, this is out 62. So let me write this 62. And now let me see. Yeah, see, we are getting the same where value of C1 is 1, you can see. Now we can plot this one, right? So now we are plotting U, which is this, you can see, in range -2 to 2. Again, we have given some commands. So let us execute this. We will get this one. Let us see here. Yeah, we will get this one. Similarly, you can solve a differential equation for a range of x. Here you have been given 0 to 30. Again, this is initial value problems, right? We will write this one. Solve. Again, I am giving the value to the solution, that is S1. Again, we will use solve. We will write differential equations. Here I am writing differential equation list form because I am going to write not only this differential equation but this initial condition as well. You can write the first one is the differential equations and the other one is the initial conditions. So that will be written in list form. We are solving this for y in term of x, where x start from 0 to 30. So since you are not getting filling, because I have already checked that one. Let's see, we will get this one. Similarly, you can now I want to write only these expressions. So I will replace yx for all from this list. The first value, what is the first value? E power 1 minus cos x. When we will execute this one, we will get this. Now I want to plot this one in the range -10 to 10. Let us see. We are getting this. We have been used percentage. That's mean I'm using the previous result. All right. So this is the graph. Similarly, you can solve the second order differential equations. Just you need to write. There is 2 dash, right, equal to 0 yx. Again, this is what? No. Second order differential equations. When we will solve this one, let me show you. We will get solutions. Since this is homogeneous equations, we will get only CF. You can see there are 2 constants, C1 and C2. So if now to plot this one, we have to remove yx here, right? So to do that, we apply rule replace all, right? The solution one, what is solution? This one, which is in list form. I am writing this one for 1, that means first element, that is this. So let me remove this one so that you can get a fill. You will get this one. Now suppose you want to see the solution curve of this, right? Yeah, family of solution of this curve. And this time I'm trying to get family of solution of this curve, right? So we will create table of solution. This is solution. How to create the table of solution? To assigning values to C1 and C2, right? So this is the table. Here I have written 105. So I should write, since this is 74, in place of 105, I should write 74, right? So in 74, we are replacing C1 by K2, K1, C2 by K2, right? So wherever C1, there will be K1. Wherever there is C2, there will be K2. And we are assigning K1 values from 1 to 5. Similarly, we are assigning K2 values from 2 to 6. So these values are for C1 and these values are for C2, you can see. So we can plot the same in -3 to 3 with this graph command for the graph. You will get this, right? So this is the family of solution of solution curve, right? If you remove this one, you will get different look, right? See here, yeah, this one, right? So similarly, we can solve the second order equations. So let me skip this one. Similarly, we can create solution for family of solution curve. Again, we have to assign value of C1, C2 for the second order. We are giving the value C1, C2 from 1 to 3 for C1, from 2 to 5 for C2. And these are some commands for plot. Whatever you want to include, you can do. Suppose you want plot legends, you can write. There are so many commands. If you are writing automatic, it will come into this term, right? Plot labels, right? Plot labels mean you can name the graph through plot labels. The graph of solution curves, axis labels, you can give the name of axis, x-axis and y-axis. Plot frame true. So see what happen if you are not giving this command frame true. You can see there will be this is something wrong, because we have to run the all programs above one by one. Let me do this. Yes, let me run this, and then we can execute this one. Okay. Plot regions, levels, access levels, plot range. It's all perfect. Yeah. What is wrong? See, here in table we are using the results in 13 output, 31. That means this time it is using this one, right? So, but we are since we are plotting this one, this function which is in output 83, here we should write 83, right? Now execute this command, you will get the solution. See. So similarly, you can use DSOL, you can find family of solutions. Again, this is family of solution curves, right? You can plot this one. Just I want to come to n DSOL, right? See here, this is transcendental, this is equation which is non-linear. Again, y is unknown, x is known. So for this, we have to apply ND-solve, right? In the range 0 to 30. And this is initial value problems where y 0 equal to 1. So again, we will give command ND-solve. Very first, we will clear all values of y as solutions, because I have earlier used this solution. That is why I am also clearing this here from this command. We are going the command ND-solve. We will write the equation in list form, because we are going not write only this equation but this initial condition too, and that is why we have written this in list form. Then this is unknown, this is the value of x in range in 0 to 30. Let me execute this. Yes, now you can, now there is no need, since this is ND-solve, so you can see the outcome will be interpolating function. There is no constant, right? We are getting interpolating functions. So there are so many things which is not necessary as we do in this solve. We will directly plot this one, right? So again, here I am writing directly. I am removing yx. I am just interested to these values, and that is why I am replacing all yx, replacing yx by solution 1. That's mean by these functions. And let me execute this. we will get this graph. To ND solve, we will get solution as a interpolating function, right? Similarly, you can solve this one. Let me do this for you. We have a system of equations. You can see this is one equation, this is another equation. At the same time, we have initial conditions. So that's mean in ND solve, we have to write 4 equations: 1, 2, and 2 conditions, initial conditions. So see here, we are writing all equations in list form. This is first one, this is second one, this is first initial condition, this is second initial conditions. And since here unknowns are x and y, we will write x and y. Please, if there is something unknown, you have to mention that unknown, which that unknown is function of which variables. So since x and y are function of t from the differential equation, you can see that's why you have to write x t y t, and similarly you have to write x prime t y prime t. And we are interested to find the solution of this one between 0 to 20. So let us find this. Again, you can see we are getting interpolating function for x and y itself. Now you can plot, right? So now see here again, when we are going to plot, this is the one, these are the only which are required, not xt yt. So what we need to do, we will replace xt by this, we will replace yt by this, and that is why this time we are writing in list form. You can see here we written only y prime x, only we are replacing yx because this is the simple ODE. But here this is system of ODE. There are 2 unknowns. So we are going to replace x and y both. And that is why we will write in list form. Solution 1 between 0 to 20. You can plot this one. Let me remove this. Run this. This is the graph, right? Again, you can define plot legends, right? If you suppose you don't have remembered the commands and you want to know the syntax, what are the syntax for particular objective. So suppose we want to know the about commands of derivative. What we can do, you can do just put question mark and d. You will get all commands related to derivative. See here, this is simple differentiation of f with respect to x. This is the differentiation of x up to nth order. This will give you the derivative of f with respect to x, with respect to y, right? That means this is second order derivative and so on. The very first, it will start from right. So suppose there is no this, we are considering only xy. So this is del 2f over del y and then del x. Similarly, this is nth derivative. We are interested to know the derivative of f for x up to order m, for y up to, with respect to y up to order m. And this will give the vector form, derivative of f in vector form. You can see. Now solution of partial differential equations. I will take 5 minutes more. Solution of a PDE. You can see. Now since here y is function of 2 variables x and t, that is why we will write y x t. That means y is function of x and t, right? So very first, to remove complexity, I am writing PDE, right? I am defining a PDE, which is the partial differential equations. You can see del y by del x, the y x t. Here x, that means y have been differentiated with respect to x. Dy xt and t, this means this is the derivative of y with respect to t, right? Now d solve, you can use d solve. PDE means that means we are going to solve these equations for y, right? Y is unknown and these are independent variables. Here, since here there are more than one independent variables, we will write those variables in list forms only. So you can see, let me show you. This is the solution, right? Similarly, you can solve this one. This is another PDE. Again, you can clear all those things what you have used earlier. So again, I am defining PDE for this equation, and since this is initial value problem. So there we will write PDE, this only, and here I am writing PDE and initial value, initial conditions in the list form as we do in UPAR OD. This is unknown and this is independent variables. Let us solve this. We will get these values. Now we can plot this one. Right, let me show you. So since there are two independent variables, so we have to plot this result. Very first, what we have to extract this one from this list. How we can do? From replace all, right? So I am considering only this. That means in place of this, you can write only this, right? That means by this commands mean we are writing this one. So here we will give the value range for x and t. So this is the plot, you can see, right? You can do the same. Let me show you. If you don't want to use, but I will advise use replace all functions. If you don't want to use replace all, you can write this function as well. In place of this one, you can write the function itself. Yes. This, and again you will get the same graph, you can see, right? So better way to extract this by this one, because sometimes there may be able to write such complicated expressions. Here we have simple expressions, so we can write, but many times we will get the very complex expressions, and that is not good to write here to plot a graph, right? Similarly, we can plot this one in the same way. You will get this one. You will get surface now, because there are two variables now, x and t. So these are things. Now the very important section is free from input. When we should, this is something text-based interface, right? Text-based interface. When we use this, suppose we don't have any idea about command and we want to execute some task, right? Suppose we want to find integral of x, sine x, right? So what we need to do, just write in like in words, sine ax, right? And here just we need to press enter, because this is text interface. Enter, right? Okay, I'm doing but we should what we need to do, just click here at plus sign, please. Here there is free form input, right? Here you can write, suppose we don't know to command how to integrate a function, so we are taking simply sine x and press just enter. For this you should have internet connections, right? So see, we have integral of sine x, that is minus cos x, right? If you want further interpretation, you can click on plus, right? So there you can see so many, right? Integral, you can find Mathematica command sine x x. Earlier you don't have idea how to do command to integrate sine x, but from free form input you can find that commands. This is mathematical forms, right? There is plotting of the same function. This range has been taken automatically by Mathematica. Again, here range has been increased from -6 to -26, right? You can write trigonometric expression for the solutions, right? You can write the series form of the money. You can see through free form input, you will get every aspect of output, right? Through free from input, you can see. Similarly, there is Wolfram alpha query. Again, you can click on plus sign. Here you can see Wolfram alpha. Suppose you want to know about tangent of x. Tangent of x. Just in the. So see, here you will get everything about tangent of x. So here it tells that your input is 10x. This is the graph of 10x, you can see. This is the another representation of 10x, right? This is another representation of 10x. This is the roots of 10x, integral roots of this. You can find domain, range, periodicity, that is tangent is function of period phi. Here you can say nature of function, whether it is subjective or injective. You can find expansions. That means these tools, whether this is preform inputs or alpha query, that are very useful for beginners, right? We can see every aspect of a command which you don't know earlier, right? So you can see in nutshell that Mathematica is very easy to learn, right? Of course, for your particular problem, you have to write your own code, but many a times, most of the time, the inbuilt function of Mathematica are enough to handle your problems. I think I spent 10 minutes more. So I think that's all.
Thank you, sir. Sir, there is a question from participant, sir. 1 minute, sir. Ma'am, question, ma'am. Sir, is there free software available for this Mathematica?
See, Mathematica is licensed version, but the plus thing with Mathematica is you can use this freely. Just you need to create a free account on Wolfram Cloud. Let me show you. I will take 1 minute only.
Okay, sir.
Just go to Google. You can search here Wolfram Cloud. Right here, you see Wolfram Cloud. Click on this, and you can create your login for free, right? If you have already account, then just sign in. Otherwise, you can to create an account. Just there is need of your mail ID, your name, right? You can create your password, and then Wolfram create a Wolfram ID for you, right? From there, you can work for the Mathematica. In that way, you can see that this is free, right? Otherwise, this is licensed version, and many a task, right? You can execute there in Wolfram Cloud, but of course, there are limited access, right?
Okay, sir. Thank you, sir. Okay, sir. Only one question, sir. Remaining is only appreciation, sir. Okay, thank you, sir.
Thank you, sir. Thank you. Once again, I want to express my thanks to all of you. And at the same time, I appreciate your efforts, what we are doing. I'm looking all these activities since 2 to 3 months. You all are doing excellent job. I'm really feel honored to associate with you with anyway. Thank you very much.
Thank you, sir.
Thank you.
I'm very proud to inform about our next program, C4, Chase, Crack, Conquer, CSIR Net. This is a free online coaching for CSIR Net aspirants. Classes will be on every Saturdays 6 p.m. to 8 p.m. and every Sundays 11 a.m. to 1 p.m. Our 10th C4 session will be held today evening at 6 p.m. Resource person, Dr. R. Sivaraman, Associate Professor, PG and Research Department of Mathematics, DG VAISHNAV College, Chennai. Next, national level webinar titled Uniform Convergence, presented by Dr. P.S. Srinivas, Assistant Professor, Department of Mathematics, Bharathidasan University, Tiruchirappalli. which will be held on 28th November at 10:30 a.m. I am very grateful and honored to propose the formal vote of thanks on behalf of PG and Research Department of Mathematics, DJ Vaishnav College, to all who spared their valuable time to make this national webinar on Introduction to Mathematica organized by our institute. I thank our most distinguished resource person, Dr. Jogendra Kumar, Associate Professor, Department of Mathematics, DIT University, Dehradun, Uttarakhand. Thank you, sir, for spending your valuable time in sharing your knowledge in view of motivating and encouraging students, research scholars, and teachers. We are thankful to our beloved Secretary, Sri Ashok Kumar Muntra, for his motivation. I would like to thank our respected Principal, Dr. S. Santosh Babu, for his enthusiastic support. My sincere thanks to our Head of the Department, Professor R. Venkatramanan, for organizing this webinar. A special thanks to the organizing committee, faculties of our department for this support and coordination. Our heartfelt thanks to all participants. With these words and a happy fulfill mood, we move to the end of the webinar. Feedback link posted in the chat box. Thank you.